I set the board so that it's bigger. Okay. Just a minute. I think it's okay today. Space is sufficient time being. Let's see how much display is coming. It's smaller. Okay, I think now most probably okay. Yes, okay. Perfect. Nothing more required. Everything all right. Black and red. Okay. Audio, video, both are okay. If both are okay, start. Audio and video both. Both okay? Okay. That's okay. Now, see, start now. Support settlement you are covering. Last time, I took one of the case. I will take everything once again. See, make a note. In slope deflection method, moment distribution method, or Carney's method, sometimes we have to consider settlement of support. How support settlement takes place, I will tell in the course, not now. Because see, this is a basic requirement. That all I won't discuss here. How that settlement takes, what actually it means. See, people tell support B, 6 by 20 mm. How sinks? There is a reason for that one. That is because of elastic support. Column gets compressed. So shortening of column, that is settlement, but we will discuss later. Now, in that case, suppose you are solving by slope deflection method, then there is a formula for end moment where theta and delta both are there. So slope deflection method, if support settlement comes, you substitute in the equation only. You don't have to consider separately. But for moment distribution method and Carney's method, there is no equation. So if a support settlement given, you have to find fixed end moment. People can call it additionally FPM. Usually FPM due to loading is there. Apart from that one, additional FPM. You have to calculate, then go for respective method. So our example is question. This is for understanding how to find fixed end moment due to support settlement. See, a fixed beam is of length 8 meter. Full stop. E is 200 GPa. I is 60 10 to the power 6 millimeter power 4. Find fixed end moments for following independent cases. Means I added something extra today. Following independent cases means when you solve case 1, case A, don't see case B. Each one is separate question. Okay, start. Before you start, write a note. We are solving the question in kilonewton and meter. Therefore, E is given in GPa, I is given in millimeter power 4. Using that given data, you get the EI value in kilonewton meter unit. It will come 12,000 kN meter square. This already over yesterday, yes or no? Tell me. This already over yesterday. Tell yes or no? Getting EI already over yesterday. Correct? I don't have to worry once again that one. Okay. Now, start one by one. A. See, A. You do one thing. I do not want to waste time here. So you should write. Whatever statement is there here, you should write that one. Otherwise it will not be clear. See. What statement written here? A left support sinks by 20 mm. Right here. Whatever I wrote there, you write here. That is A is left support sinks by 20 mm. See, first of all, your fixed beam is like this. This is the fixed beam AB of length 8 meter. Okay. Now, what you have to do is, see, correctly observe how to decide. First, do one thing. Draw light line. Light line. This is the initial position. Means before support settlement. See, you write here. This dotted line is initial position. That is before support settlement. This is initial position. Initial position, that is before support settlement. Support settlement. This is A, this is B. Okay, clear? Initial, see the point A is here, point B is here. Length is 8 meter. Clear now? Initial position. Clear? Okay, now what you do is correctly observe how is the settlement. It is given, what given is here? Support, left support sinks by 20 mm. Okay. Do not write there. Somewhere, yeah, now after that one, see. Okay, I'll do one thing. I can write here, means so that it is easy for me. Instead of wasting time, I can do in single stretch only. Okay, 1 minute. See. This is dotted line. This is initial position. Initial position. No, I want separately. Again, what happens is A, B, C, D problem will come for you, not for me. Clearly. First light line. This is permanent, same for all questions. This is A is here, B is here. Initial position. Initial position, that is before settlement, before support settlement. Okay, correct. I wasted time. Okay, now do one thing. Draw one more line. Once again draw the initial position. See, once again draw initial position. Right here. Dotted line is once again initial position. See the question. Left support sinks by 20 mm. So, this support at left end sinks. It will come here. So, do one thing, that A will move here. Some people call A dash. No, I don't want to call A dash. Then what will happen is, you have to write A here, A dash comes here, confusion comes. Our important is understanding. Someone will tell, it is A dash. Why? I am calling A. Who are you to tell? That position, that point A shifted here. Do not talk nonsense, I will tell them. This is how they understand. So, what you do is, point A will shift here. Okay, this is A. See, here. This will sink down by 20 mm. Okay. Then, support, left support sinks by 20. Right support, nothing. So, right support will remain there only. This is the final position. This is the final position. Final position of supports. Final position of supports. Clear? Tell me. Final position of supports. Fast. Clear? Okay. Now what you do is, see, this kilometer meter square is causing trouble. Hey, come this side. Where are you going that side? I will tell EI. Hey, don't go that side. EI equal to 12,000 kilonewton meter square. Okay. Now you keep quiet. Okay. Now, what you do is, draw two parallel lines. See, draw two parallel lines. Why two parallel lines? I will tell you. Scale not required. Two parallel lines. This is how you understand. See, now why two parallel lines? Because this is, don't worry about that one. Don't see there. Why draw two parallel lines? I will tell you. This question, as per question, it is support A sinks by 20, support B nothing. Or you can also tell this is with respect to B, support A comes down by 20. Or you can also tell this as with respect to A, support B is what? 20 mm up or down. Tell me. If you stand at B, you can tell A is below by 20. Suppose I stand at A, what you will tell? B is what? Below or above? B is. If I stand at A, you can tell support B is below or above. What you can tell? Both are same meaning. Below or above. No, correct. It is above. Like, see, somebody is in the, see, 4th floor. Somebody is in the 7th floor. Who is in the 4th floor? 4th floor is here. 4th floor. He will tell other person is 3 floors above me. One who is in the 7th floor, he will tell other person is 3 floors below me. Both are same. Depends upon who is talking with respect to whom. Now, see here, what to do is, see, A is here. Fix it, A. B is here. B is here. Somewhere outside, project here. See, this is your delta. Delta. Delta is relative displacement. With respect to A, how much is the displacement of B? Or with respect to B, how much is displacement of A? Delta equal to 20 millimeter. But you are substituting what? In kilonewton and meter, or it is 20 by 1000 meter. Hope covering the full board. Okay. Now draw elastic curve. I will use red color for elastic curve. See. Okay. Zero slope. I told you 1000 times. I will not repeat. If you stand at A, it has gone this way. Now we want to prevent it. I told you it's a preventing case. Actually, technically, for zero slope, it is so crystal clear. This is clockwise. This is also clockwise. Correct? It is crystal clear. See, because of elastic curve, or those who find difficulty can do one thing. You stand at A, push B upwards. See, it goes this way. If it goes this way, preventing that going is like this. Or if you stand at B, push A down. It is rotating like this. Now, to prevent the rotation, you require like this. Or delta, I told, is always preventing case. This I explained earlier with the car example, etc. Fully clear? This I explained earlier with the car example, a driving example, turning case and preventing case. Tell me yes or no. If you tell yes means over. Yes. Okay. Now, you don't have to bother. Both FPMs are, how much answer? 6 EI delta by L square. This is also 6 EI delta by L square. Now, go to calculation. Space is there? Yes, space is not there. Below space is there. Therefore, see, with the clockwise positive, M bar AB and M bar BA equal to, substitute, both are 6 EI delta by L square clockwise plus, that also plus 6 into EI is 12,000 into delta is 20 by 1000 divided by 8 square. Tell the answer. We got yesterday. Tell the answer. That is the FPM at A. Answer. 22.5 kilonewton meter. See, or 22.5. This is plus 22.5 kilonewton meter. M bar BA also is clockwise. Don't calculate. Put plus 22.5 kilonewton meter over. See, if it is a loading case, one is anti-clockwise, one is clockwise. But settlement case, both are clockwise or both are anti-clockwise. Now, question A is completely over. I will go to B. B. B is, I will keep on solving now. Correctly understand. B. Left support rises by 16 mm. You write once again here. What I wrote there, you write here. Left support rises by how much? 16 millimeter. So you put dotted line here. B will remain there only. A will go here. Your A will come here. This will go up by 16 millimeter. This is the relative displacement. Therefore, if I draw two parallel lines, tell me answer now. If I draw two parallel lines, what will happen? If two parallel lines are drawn, tell what will happen now. See, this is A here. Or I'll put outside, I'll put, instead of wasting, see, 16 millimeter. Tell me, A is here, B is here. Tell me, if I draw two parallel lines, which I should, see, here, which I should write up, left side. A I should write upper side. See, if A is here, then B is here. Now, see, now somewhere here, project. This is your delta. Delta is that important term. Delta. The delta equal to, see here, this is 16, this is 0. So 16 millimeter or 16 by 1000 meter over. Now elastic curve will come like this. See, this way. Now moments are, see, this way. Anti-clockwise here and here also anti-clockwise. Formula once again, 6EI delta by L square. This also 6EI delta by L square. Okay, now clockwise positive, your M bar AB, M bar BA, both are anti-clockwise, minus, minus. Delta equal to, how much now? Now delta equal to 16 by 1000. Tell the answer. Answer. Delta equal to 16 by 1000. Answer. Minus 18. This is minus 18. This also minus 18 over kilonewton meter. Case B is over. Come to case C. Okay, right. Whatever I wrote there, right support sinks by 12 mm. Write it here. Right support sinks by 12 mm. So now your position is, see, here your right support sinks by 12 mm. 12 millimeter. Whereas left support will remain there only. Right will come down. Now if you draw two parallel lines, tell me answer. If I draw two parallel lines, A is once again upper side. See, B is lower side, A upper side. Tell me, what is delta now? Elastic curve will once again be like this. See here, A is upper side, B is lower side. So it is tilting this way. To prevent, you require anti-clockwise. Tell delta now, fast. Delta. Delta equal to 12 millimeter or 12 by 1000 meter. Substitute 12 by 1000 here. Answer. Again anti-clockwise. Answer. 6 into anti-clockwise. You draw one more sketch. Answer. Answer. 12 EI delta by L square. Minus 13.5. Minus 13.5. This also minus 13.5 over. But you should not do this way. Every case you have to write separately and get the answer. Now, come to question number D. D. Okay. Black everything. D. What is D? Right support rises by 24 millimeter. Okay. Final position. How is it? A is here. See. Final position. They told right support rises. So left will remain there only. Your right will go up. B. The rising of support. Why rises? You don't bother here. Because that comes later. How much? 24 millimeter. Okay. Now this is B. Now therefore, if I draw two parallel lines, see here now. In case I draw two parallel lines, some will tell why parallel lines. I will tell them keep quiet, don't talk. That is the best way of deciding. Confusion. Draw two parallel lines. Because you cannot tell, this you can tell with respect to A, B is upper side by 24. Or you can tell with respect to B, A is below 24. So therefore, don't comment. Okay. Now, A is below, somewhere here. B is there. A is here, B is there. Somewhere here, project it and write delta equal to how much? 24 millimeter or 24 by 1000 meter. Elastic curve, see. Now, member will go this way, balance, preventing is clockwise. This is clockwise, this is also clockwise. Formula, 6 EI delta by L square, 6 EI delta by L square. Therefore, both FPMs are clockwise. Answer, 6 into EI into delta. How much? 24 by 1000. Tell the answer. 24 by 1000. Answer. 24 ಎಲ್ಲೂ ಇಲ್ಲ. 12 ಎಷ್ಟು ಬಂತು? 12 double. What you got last time, double will come. How much? 27. This is minus 27 kn meter. This plus. This also plus 27 kn meter. So we covered left sinks, right keeps quiet. Left rises, right keeps quiet. Then left keeps quiet, right sinks over. Left nothing, right rising over. Okay. All 4 cases clear? All 4 cases fully clear? Actually, that's all. All 4 cases fully clear? If this is clear, further is nothing. Okay, but still to understand further. Further. Start. Next one. Fifth D E. E. What is E? D okay. E. Left support sinks by 25 mm and right support sinks by 9 mm. Okay. See, right here. Left, see. Now, draw once again initial line. Okay. Initially, A is here. What they told? Left support sinks by 25 mm. It will come here. A. So, this sinking is 25 millimeter. Whereas, they told right support sinks by 9 mm. This also sinks by how much? B comes here. This is sinking by 9 mm. Okay, now draw 2 parallel lines. Tell me, A is below or B is below? Tell the answer. By looking only you can make out which is below, which is below. A below or B below? Tell me that much. A below. So somewhere here mark A. Now with respect to A, mark B. Clear? So tell me correctly now, what is your delta? Tell me delta now, correctly. Delta equal to, it is neither 25 nor 9. What is delta? Neither 25 nor 9. Delta. Delta is the relative settlement. It is 16 millimeter. Delta is 16 millimeter. How we got 16? 25 minus 9 or equal to 16 by 1000 meter. Elastic curve. Okay. This is your A. This is your B. Now, as usual, see, goes this way, clockwise moment. This is now mechanical. After some time, mechanical formula. 6 EI delta by L square. This also 6 EI delta by L square. Substitute. Delta equal to 16 by 1000. Anybody can tell the answer? Both are clockwise. Answer. 16 by 1000. Already 16 answer is there. Second answer it is. What is the answer? Plus 18. Okay. Plus 18 plus 18. Plus 18. Okay. Now, E over, go to F. Where is F? Left support sinks by 13 millimeter and right support sinks by 21. See here, left is sinking more, right is sinking lesser. Next question is other way. How? Next question, F question is left sinks by 13 millimeter. See, this is sinking by 13 millimeter. A will come here. How much? 13 millimeter, whereas B sinks by 21 millimeter here. This sinks by, B goes here, 21 millimeter. Okay, now, once again, what you do? To understand correctly, little boring to write every time. I can stop this up sometime. See, now what you do is, once again, you make a rule. Two parallel lines. Now, with respect to B, A is above. And with respect to A, B is below. This is A, this is B. Somewhere here, this is delta. I won't tell you how you calculate. Tell the answer, delta. I won't explain. Delta. I won't explain now. Why? High school students will tell the answer. Delta, 8 millimeter. Suppose someone not able to know how 8 mm, leave the class. Don't come back once again. Equal to 8 by 1000 meter. Elastic curve. This way. See now. Once again. This way, it goes this way, anti-clockwise. Now you write the formula 6EI delta by L square, 6EI delta by L square, substitute delta equal to 8 by 1000, get the answer. Both are anti-clockwise. Minus, minus. What is the answer? Both are anti-clockwise. Answer. Both are anti-clockwise. -9, -9, over. -9, -9, over. Now, EF, G case. See, what happened is, one question, first question, A sinking, B nothing. Second question, A rising, B nothing. Third question, B sinking, A nothing. Fourth question, B rising, A nothing. Fifth question, A sinking, B sinking, but A sinking more, B sinking lesser. Last question, A sinking lesser, B sinking more. EF, G. G is both supports sink by 21.8 millimeter. See here. Support A and B. See, one question, A is sinking more, B is sinking lesser. Now, both supports sink by what? Both support sinks by how much? This is sinking down by how much? 21.8 millimeter. This also sinks by 21.8 millimeter. Therefore, A is here, B is here. Now, if I draw two parallel lines, you are in problem. Why? Suppose I take A here. Where is B? Tell me. If I take, okay, I'll do one thing. Two parallel lines. Okay. If I take A here, where is B? Above A or below A? Where is B? Where is B? Where is B? Above or below A? If I take A somewhere, same level. So, both support sinks by same. Therefore, this case, delta equal to, how much tell me? Delta equal to I will give an example later to understand. Delta equal to how much? Now delta. Relative settlement of one end with respect to other. Delta equal to answer. Fast answer. 0. Therefore, both, don't calculate, both FPMs are 0 and 0. Over. Clear? Further questions, shall I show only delta and show the moment and stop? Further question, shall I show only sketch, moment, answer not required? Agreed? Further, I cannot waste time. I will write the sketch, answer not required. Okay, see, so that some time is saved. We don't want to waste time here. Same problem. Which one? That rubbing one. Where I throw it? Once I used it, somewhere I thrown it outside. Here. Okay. Now, see, correctly. G over, little careful now. This formula I am not using now. So, correctly I'll explain. See, after, which one over now? G over. H. Left support sinks by 6 mm. See here. Left support sinks by 6 mm. A comes here, sinks by 6 mm. Right support rises by 10 mm. B rises by 10 mm. Okay, then if I draw two parallel lines, tell me A is below and B is above. Elastic curve will be, how elastic curve? See, it will come this way. Now, since it goes that way, both FPMs are clockwise. Formula, I won't waste time. This is A, this is B. And now tell me what is delta. My problem is over. Then, usual, both are clockwise plus 6 EI delta by L square. Don't waste time. Delta. Delta. 16 millimeter. Why 16? Some will tell, sir, one is going down, sir, other is going up. That's why 16. Okay, correct. Fully clear? No time waste. Fully clear. Other next one, I'll cut short. Full clear? First tell me. Full clear? I'll go to the next part. Clear. Okay. Now, further all, I won't waste time. So fast, see. Bah. This is horrible. I see here. I should next time, I should tie it to the neck only. Okay, now, see there. H over I. Left support rises by 4, right support sinks by 8. Left support rises by 4. Okay, color change. This is A. Right support sinks by, left support rises by 4, right support sinks by 8. This is A, this is B. Tell me correctly, A is upper side, B is lower side. Elastic curve is like this. Both are what moment? See, if it goes this way, both are anti-clockwise, anti-clockwise. Same thing. Tell me, what is delta now? Delta. You tell delta, then substitute. Both are anti-clockwise, minus, minus. Delta. How much delta? Delta equal to 12 millimeter or 12 by 1000 meter over. Fully clear? Okay, now, it is not clear, nothing can be done. Okay, next. All you write separately. I. Where is I? I over, oh sorry, H over, I over. I also H over, I over. Next J. Okay, maybe I made a mistake in ABCD. See, J. Left support rises by 2 mm. Rises by 2 mm. A goes here. Rises by 2 mm. Right support rises by 10 mm. Right support rises by 10 mm. Therefore, if I draw two parallel lines, now see, A to B I want. A is below, B is above. See, from A to B, elastic curve like this. Tell me delta. Delta. It is not 12 now. Delta. Now delta. 8 mm. Why 8 mm? 8 mm. Now, see, since it goes this way, both are clockwise, clockwise. Over. Now substitute, get the moment. J over, lastly, K. K. Left support rises by K. K. Left support rises by 11, right support rises by 5. Same way, see here. Left rises by 11. A goes here by 11. Right support rises by how much? 5 mm. Now, if I draw two parallel lines, A is upper side, B is lower side. Elastic curve will come this way. Moments are, it goes this way, both are anti-clockwise, anti-clockwise. Tell the answer. Delta equal to, fast. Delta equal to, oh, almost over now. I will tell an example for you. Delta equal to 6 mm, correct. 6 mm. Now, lastly, L. L is both supports rises by 7.5 millimeter. L. A goes up by 7.5 millimeter. B also goes up by 7.5 millimeter. So, therefore, A and B both are same level. Tell me, delta equal to A goes up by 7.5, B also goes up by 7.5. Same direction. Delta equal to 0. It is fully clear? Okay. Now, I will give an example for you. You should correctly tell delta for me. Remember, up to your end of the course. Imagine in a building, this is a standard level. See, this is floor number 5. Floor number 5. This is the main floor. See, maybe in a building, what happens is, from outside, a direct entry to 5th floor. It is a standard floor. Some floors are above, some floors are below. Floor 5. Now tell me, somebody is in here. Somebody is in 3rd floor. This is left side, right side. Okay. So just imagine floor level. See, 2 people, A and B. A is in floor 5. A in floor 5. B also floor 5. Tell the answer. Delta. Both are in floor 5. Answer. Neither of them moved. Answer. How much? Delta. 0. Or A comes down to 3rd floor. A. B also comes down to 3rd floor. 3rd floor. Tell delta. A from 5th floor, he will come to 3rd floor. B also come down to 3rd floor. How much? 0. Or A goes to up to 9th floor. B also goes to 9th floor. Tell delta. Delta. A goes to 9th floor. B also goes to 9th floor. Again 0. Now, A remains here only. B goes to 1st floor. Answer. He will go down to 1st floor. Delta. A is in the 5th floor only. B has gone down to 1st floor. Delta. Where is B with respect to A? Delta. Answer. Think a little and tell me. Delta. A is there only. A has moved, not moved. B is delta equal to 4. Or A goes down to 1st floor. B goes down to, this is the 5th floor, 4th floor. Delta. From A will go down to 4th floor. B will come down to, A will go down to 1st floor. From 5th floor, he comes down to 1st floor. B comes down to 4th floor. Delta. Delta. 3. Why? He is in the 4th floor, he is 1st floor, 3. Or A goes up to 6th floor, 9th floor. B goes down to 3rd floor. Delta. A goes up by 9th floor. B goes down to 3rd floor. Delta. Oh, this is very careful now. 5th floor, he has gone to 9th floor. 4 floor above. He is 4 floors above. He is 2 floors below. 6. Fully clear? Now, remember, practically, in a building, if column settlement takes place in case of footing, have you heard it? Settlement of footing, have you heard of it? That is the most, a term called unequal settlement, very dangerous for buildings. Heard of it? Unequal settlement of soil is dangerous. Heard of it or not? Unequal settlement is called dangerous. Heard or not? Yes. Now, if 2 columns, if they both settle by same amount, tell what happens? That is called uniform settlement. Tell what happens? What happens? If both the footing settle by same amount, what happened? Is it okay or danger? Both the footing settle by same amount. Nothing. See, relative settlement is not there. That's why uniform settlement is better. Or, remember, if one comes down, if other also comes down, or other goes up, tell danger. One coming down, one coming, other one coming down better or going up better. If one of them is going down, it is better, other should what? Come down or go up. Which is better? If one of them decided to go down, better go down. If they go down by same amount, no effect. Delta becomes 0. Now I will tell you one more example. See, I told sometime one support sinks. Sometime both support settlement. Yes or no? One support settle, only one support settlement or both support settlement. I told that way. See, we considered so many cases here. Sometime only one support settlement. Sometime both settlement. Clear? Okay. Now, best example is in a road. See, I won't write in the board. A driver is driving a car at 100 kilometers per hour speed. Tell me, suppose there is another car going at 100 kilometers per hour, same speed. By chance, because of some reason, this vehicle will touch that one. Tell what will happen. Another car is going at 100 kilometers per hour. From behind, you are also going at 100 kilometers per hour. Due to some small problem, almost nearby, by chance you touch. Tell me, danger or nothing? Danger or nothing? Tell me. If you touch another vehicle which is going in the same direction and same speed, tell me, danger or nothing? Fast. Or minor scratches. What you can tell? Slight paint gone, some small sound. Tell me, what is that one? One is going at 100. From behind also, you come at 100 speed and touch, almost touch. Tell me, disastrous or no problem? Fast. Disastrous or no problem? Fast answer. Is it disastrous case or no problem? Why this much time? You are from behind, you touch a vehicle which is running almost at the same speed. Tell me, disastrous or no problem? At least answer. Think a little. Is it disastrous or no problem? No, if you don't answer, I can't continue. Disastrous or no problem? This much time to comment. Then, no problem. No problem. Why problem case? Minor leave it. Scratches or leave it. Don't worry about scratches. Maybe some verbal fighting. Hey, Nodkobara. Like that. Will it be a disastrous case or minor case? You should tell disastrous or minor. Almost touching. Both are same speed. Why problem case you are telling? If you answer that way, I can't answer. Minor, nothing. Why? Relative speed is 0. Correct? Okay. Now, a car going at 100 kilometers per speed hits a parked vehicle. A truck is parked on the road. You know, in paper comes. A car, reckless driver, he was going at 100 kilometers. Ninta lorige karu dikki. Nodi, ninta lorige. Another car is, a truck is parked. Heavy truck is parked. This car will go and bang him at 100. Tell me, disastrous or no problem? Or either hit a parked vehicle or hit a tree. Tree is not moving. ಕನ್ನಡ ಬರುತ್ತೆ, ಮರಕ್ಕೆ ಕಾರು ಡಿಕ್ಕಿಯಾಗಿ 5 ಜನರ ದುರ್ಮರಣ, ಕಾರು ಮುದ್ದೆ ಕಾರು ತೋ ಚಲ್ಲಾಪಿಲ್ಲಿ. Tell me what? Disaster. Now, further disaster. What? A car is going at 100 kmph, another car is coming in opposite direction at 100, head-on collision. Tell me, is it worst case or best case? Head-on collision. One going this way, one coming this way, head-on collision. Is it more disaster or less disaster? It is the worst case. Why? First time, going at 100, touch at 100, relative 0. Then second case, that is not going, hit at 100, relative speed 100. Now, tell me relative speed. If you go by 100 this way, other hits by 100, tell the impact speed. Impact is due to what speed? Not 100. Tell how much? The impact accident is due to what speed? Tell me. The accident effect is for what speed? If you go at 100, another somebody else comes in opposite by 100 and head-on collision, it is 200 effect. Why? See, one support goes down, other support goes down. Good. Both go down, same means no effect. Otherwise, little effect. But if one comes down, other goes up, disastrous effect. Delta will increase. Tell me, crystal clear? If crystal clear, I will go to next case. Tell me fast. If crystal clear, I will go to next case. Fast I will go. I won't waste time. If it is crystal case, I will go to an example of loading and then go for final part. See, now, last part of this pre-requirement. Then I will tell you the result required, what derived in the class I will write today. See, 1 minute. Now, last part of pre-requirement. See, this is all individual example. What I have given just now is just individual examples. Now I will go for an example where you correctly understand how to find FVM. And remember, later, when I go to MDRT Kani's method, when this comes, I will not explain. See correctly now what I am doing. Okay, not much. See, first question I will write. You take a beam here, see, fixed end. One support here. One more support here. 1 minute. One more support here. A, B, C, D. 1 minute now. Sinks. Okay, that's enough. Sufficient. No point in wasting time. Too much. Correctly understand. 5 meter, 6 meter, 4 meter, and once again 6 meter. Now, to save the time, what I will do is, I will put a point load here of 80 kilonewton. Here I will put UDL. Here to here I will put UDL. This 80 kilonewton I will give at 2 meter. This UDL is some 30 kilonewton per meter. And here I will put a central point load of only 20 kilonewton. Saku. 20 kilonewton. A, B, C, D. One master example. Once this is clear, nothing further. Central load. So this is at 3 meter. Okay. Now, given in the question, support at A sinks by 6 mm, comma, support at B sinks by ಒಂದು 16 mm. Support at C sinks by, A sinks by 6, B sinks by 16, C sinks by 6 meter, 16 ಆಯಿತು, 16 ಅಂದರೆ 4 millimeter ಸಾಕು, 4 millimeter. Next, support at D
sinks by 4, this sinks by 4, that sinks 15, 16 ಬೇಕು 20 ಬೇಕು ಅಂದರೆ 4. Why you don't know? 24 millimeter ಹೋಯ್ತು, ಪರವಾಗಿ ಬಿಡಿ. And lastly, support at E sinks ಅಲ್ಲ, support at E, I will tell, rises by. Why rising? ಅಯ್ಯೋ, given in the question, rises by 6 millimeter. ಆಯ್ತು, 6 ಬೇಡ, 9 millimeter. 9 millimeter over. E equal to 200 GPa steel and I equal to ಒಂದು 80 ಬೇಡ, multiple of 2, 60, 90, 10 to the power 6 millimeter power 4. For this question is find fixed end moments considering loading and also given support settlements. Once this question is over, what I will do is I will go to the concluding part, that is for slope deflection method, for moment distribution method and for Carney's method. There are 3 important factors. Number 1, rotation of one end with the fixity at the other end, 4 EI by L, 2 EI by L. Then rotation of one end when other end is simple supported, 3 EI by L. You get the stiffness there and carryover factor there, and settlement of support 6 EI delta by L square, which we are using for derivation. When I go to SD method and MD method and Carney's method, I am going to derive each and every method, not simply tell the procedure. We will start system, that is the course, not now. YouTube class will stop today. Remember, YouTube class will end today. These 3 methods I already published there. Analysis of indeterminate structures will start on 13th of December. Those who are in the group, I will tell you later. 13th December, weekly, Tuesday to Friday, 7:30 to 9:30. There, these 3 methods will be systematically covered with full understanding. And one important, there are some pre-requirements for that one. All those pre-requirements are covered here. At present, it is a pre-requirement. So, even those who come join that batch, I will tell them, before, as soon as they join, some are joining now, I told them, as soon as before 13th December, see YouTube in the playlist indeterminate structure pre-requirement. Today is class number 8, class 5, 6, 7, 8. Yes, class 5, 6, 7, 8. Thoroughly study, because that is required. One of them told, sir, I already studied. Very good. So that is for them. Others, general public, today this is going to close. YouTube class. I told the reason also. Even indeterminate structure also, I would have continued in YouTube only, so that I am not that type of person to make a separate batch. But people don't come to the class. If they come, they don't answer the question. Keep quiet. Average view, they will come and view for 1 minute, 2 minutes. What they are doing? Just visiting for fun. No response they are giving. So I decided, they don't deserve this YouTube free class. They don't deserve it. So if they want to learn, let them join. So otherwise, I first thought everything I do in YouTube only. But then it's a penalty for those for not showing interest. You should realize, my class, see, if I make a mistake, or if I don't tell correctly, or if I struggle, tell wrong things, struggle, make a mistake, then okay, you tell, hey, this person does not know. Show me one instance where I struggled. Okay. Now start. Start now. See, first to make a note. Note. What we are doing now is required later for SD method, MD method and Carney's method. And fixed end moment, our symbol is M bar. we will get in kilonewton meter and clockwise positive. I told you. I won't repeat once again. This is the master example. Then one thing forgotten, I write something else here. See, 2EI, 3EI, I'll change the EI also. This is 1.6 EI. This is 2 EI. I forgot EI change. In the question given. Okay, start. Clockwise positive. First remember, when you consider loading, you get load and span. It is visible here. Okay. EI will not come. But when you consider settlement of support, formula is 6 EI delta by L square. Therefore, we require EI in that unit in which you are finding moment. We are finding FPM in kilonewton meter. So we want EI in kilonewton and meter unit. So first write given E equal to 200 GPa, I equal to 90 10 to the power 6. Using that given value of E equal to 200 GPa and I equal to 90 10 to the power 6 millimeter power 4, you whatever you want to do can do. You get EI equal to, tell the answer. Tell me the EI answer in kilonewton meter square. I will write here. So conclusion, remember, for all substitution, your EI equal to, I am rubbing that one. Tell the answer, EI in kilonewton meter unit. EI fast. 18,000. EI becomes 18,000. Remember, it is 18,000 kilonewton meter square. Okay. It will come 18,000. Now, is this what I wrote fully clear? I want to remove this one now. What I told now, is it fully clear? I am rubbing and starting fresh now. What I told, fully clear? If it is clear, I will start numerical. Yes, start. Now, same problem. I threw it somewhere. I am rubbing this one now, remember. FPM symbol M bar, kilonewton meter, clockwise positive. I won't tell again and again. There is a limit. First of all, I should stop some of my statement telling repeatedly. But what to do? I am always very much student friendly only. Start. First step, right? We have to combine loading and settlement both. Remember, for MD method and Carney's method, if it is slope deflection method not required, the delta comes in the equation. That will worry later, not now. Okay, start. Now, loading, no problem. So, settlement point of view, first do one thing. You write, see, calculation of FPMs, considering what? Considering given loading, and also given support settlements. Okay, start. First do one thing, light line. You put a, see, what you do is, you write light line, initial position, before settlement, what is the situation? See, now, this is A, this is B, how much? 5 meter, B, this is B, C is 6 meter, D is 4 meter, E is at another 6 meter, okay, E. This is the initial position before settlement of supports. Okay, now, with respect to this one, now do one thing, draw one more sketch. How is the settlement? One more sketch. It is very ideal to write. See, now do one thing. You do not call A. You move it, do not call A. Or you can do one thing. Once you put this sketch, you remove this A, B, C, D. Now once again write. See here. Support A sinks by 6 mm. So A comes here. This is down by 6 mm. Support B sinks by 16 mm. Okay. B comes here. This is B down by 16 mm. Support C sinks by 4 mm. Barali. That's all. C down by 4 mm. Support D sinks by 24 mm. Okay, namgenu. Dudu kodtiva. D 24 mm. Unfortunately, support E rises by 9 mm. This is E, which goes up by 9 mm. Is this sketch fully clear? This is the final point where A is here, B is here, C is here, D is here, E is here. Suppose any settlement is not given, that point you mark in the beam only. See, suppose a question given here. Only support B and C sinks, then A will remain there only, B will come here and C will come here. So, this is the given support settlement. Given support settlement. Tell me, is this sketch clear? That's all. We will start now. Yes, clear. Now do one thing. Start considering member after member. First, consider AB. See correctly. It will take some time today. Or I will do one thing. If it takes little more time, then the pre-requirement of that 4 EI by L, 2 EI by L, 4 EI by L into theta, carry over part, and 3 EI by L, and those things all, I won't give here, no problem. I can give it in the regular class when I start the course. Why? Because I need not give here. Some will tell, sir, we are not there. Okay, you learn whatever I tell. Don't ask for more. If it is not possible today, I will give it when I start the course. It's better that way. When I start I am feeling, even today also I am seeing, so many people came and go, coming and going. Randomly, I will see that more than 70-80 people came, but none of them commented. At least one comment. Involvement is not there. So, therefore, I may not tell. Sometimes you have to be harsh. Then only people understand. Okay, start. Now, AB. Make a note. Draw 2 sketches. First of one of them for loading. AB comes here loading. This way. AB. A is here, B is here. Span you write here. How much span? Span is 5 meter. Span is 5 meter. Okay. There is point load of how much? 80 kilonewton at from here to here is 2 meter. This is 3 meter. If you remember, this is 2 meter, 3 meter. 2 becomes A, 3 becomes B. Span is 5 meter. Okay. Now, correctly mark FEM. I told loading case. This is anti-clockwise. This is clockwise. Answer. WAB square by L square. WBA square by L square. Now, this is for loading. Below, do one thing. See, correctly below. Project down. Project down. Then, draw 2 parallel lines. Draw 2 parallel lines. Remember, 2 parallel lines are required. Now, come here. A is here, B is here. Tell me, if I draw 2 parallel lines, I want to locate A with respect to B. Tell which is upper side, fast. Which is upper side? Which is upper side? Yes, see, once again, so many people came, went back. They just come for inspection purpose. Such people I will never call my students. Which is upper side? A is upper side. So, you should write A here. If A is here, B is here. So, see, A here, B here. Then project here. Tell me correctly what is delta for this member. First, observe this sketch and tell me calculation you should write. How it came, high school mathematics. Tell the answer. Delta. Delta is 10 mm. If someone tells, sir, not clear, I will tell better not study engineering. This is down by 6, down by 16. A to B, this is 10. If not clear, not fit for high school mathematics, or equal to 10 by 1000 meter. Elastic curve will go this way. This all told for you. Now, see, loading anti-clockwise, clockwise. Here, member goes this way. So preventing case, anti-clockwise here and also anti-clockwise here. Therefore, space is not there. I will calculate here m bar AB, and then I will calculate m bar BA here. I hope space is sufficient. Can you see it? Okay, I can manage. Or 1 minute, because space problem is there instead of there. Okay, space problem. Shall I remove this one all? I can remove this one, correct? I can remove this one. Okay, I can remove this one. EI is, remember, 18,000. Okay, so remember now, your EI is 18,000 kilonewton meter square. Okay, I can write here. See, now start, because my free space. So this case, you write here, not somewhere here. M bar AB, I want both of them. M bar AB and M bar BA. Remember, clockwise positive. See here, due to loading anti-clockwise, minus, write the formula here, minus, start. 80 into 2 into 3 square divided by 5 square. Fully clear? If it is not clear, there is no point in 1 nimisha. Here I start. Space required. M bar AB, little later M bar BA. Okay, start. M bar AB. See, AB, anti-clockwise, minus 80 into 2 into 3 square divided by 5 square. And then here, it is anti-clockwise formula. What is the formula? 6 EI delta by L square. This also 6 EI delta by L square. Therefore, see, this is anti-clockwise. Once again anti-clockwise. Again minus 6 into how much EI? EI is 18,000. 6 into 18,000 EI delta. Delta is 10 by 1,000 divided by L square. How much square? 5 square. Anybody can tell the answer? M bar AB in kilonewton meter. Then M bar BA, see, clockwise, plus W. 80 into 3 into 2 square. 2 into 18 into from that side. 18 into 3 into 2 square by 5 square is clockwise due to loading, but due to settlement anti-clockwise, minus same as that answer. 6 into 18,000 into delta is 10 by 1,000 divided by 5 square. Anybody can tell these two answer with the proper sign? Tell the answer. First one. ಸರಿಯಾಗಿ ಮಾಡಬೇಕು. Don't give wrong answer. 80 into 2 into 3 square divided by 5 square, negative, again plus 6 into 18,000 into 10 by 1,000 divided by 5 square. It is coming plus minus 144. Minus 144. This is coming then this is into minus 1. Coming minus 48. Correct answer. First one is coming minus 144. Second is coming minus 44. It's first one. Plus 8.4. First one. What is the first one? Minus 87.6. Another one 87.6. Innondu 8.4. Why? I'll check once again. Why that much problem? Square is 25. 86.4. 86.4 means correct, minus 144. Other one. Minus 40. Wait, correct agidiyalla answer? My answer correct. Check once again. Check once again. How much? My answer correct or wrong? Tell fast. My answer, see, those people who came, they vanished once again. See, not a single one has commented except one person. Tell me, my answer correct or wrong? My answer correct or wrong? Fast, fast, tell me. Don't waste time. For AB, minus 100.8. For BC, how much for BC? For BC, how much? For BC. For BC, you are getting 8.4. Please check once again. Okay, no problem. You check once again. I'll take some 2 minutes break. Agreed? Because non-stop I am talking. I'll take 2 minutes break. During break time, you check it. For that matter, remember, my answer is correct. My answer is correct. I am not checking it. That means there is something important. You made a mistake. Some mistake you made. See correctly and decide. Agreed? You check the correctly, see the question and also calculation and correct the mistake. Agreed? Correct your mistake. This is the mistake so many people will do. So what I did was that mistake people do, I also did the mistake. But when I write the answer, I wrote correct answer. When I wrote the answer, I wrote correct answer. I won't check once again. Will you 5 minutes time? Will you go through again? Tell me. 5 minutes time. Can you go through again? Go through the board once again. Tell me. Just 5 minutes time. Can you go through the board once again? If yes means, see, non-stop I am talking for more than 1 hour. You are not answering. 5 minutes time you go through the board again. I will tell you. Don't worry, I will correct it. That is, I made a deliberate mistake. You fell for it. You see now. What is the mistake? Correctly observe. Just 5 minutes. I will come back. I will come back in 5 minutes.
I'll start. Those who are regular, attend the class. Others, don't worry. I told already. Okay. Shall I start? Tell me. Shall I start? Shall I continue? Voice clear? Shall I continue? Voice clear? Yet I want confirmation. Yes, okay. See, you should be careful. In the question they told, see here, this is 2 EI, 3 EI, 1.6 EI, 2 EI. That is, you should correctly observe the question. I wrote here G. G andre gottu anta. So, when I take member AB, see, it has got 2 EI. So, better you write here, this member has got 2 EI. Danger. Therefore, formula is 6 EI delta by L square for the member AB. This is for the member BA. Therefore, what you have to do is 6 into EI. See, your EI is 18,000. What do you have to do? Tell me. Bracket. Tell me how much you have to multiply here. 2 times of 18,000. Here also. Bracket. Don't forget 2 times of 18,000. So you write here. Do not forget me or nannannu marayabedi. Be very careful. Mujhe bhulna nahi. That relate EI. See, general EI is 18,000. It has got 2 EI here. Therefore, you have to write 2 times of 18,000. 2 times of 18,000. Is the mistake clear? Tell me. Is the mistake clear now? Is the mistake clear or not? What mistake you made? Everything you did correctly, but you did not correctly observe the question. Clear your mistake? Fast. Your mistake is clear. Okay, now tell the answer. Fast. Now you want to waste time. Now I'll finish fast. Today. Now not much work. So that EI, do not forget me. Kannadadalli. Nannannu marayabedi. Because, tell the answer now. Now tell the answer. You change the numerical. You put 2 times. Don't forget this 2. Now tell the answer. Now, what answer I wrote? Is it correct? What answer I wrote? Correct or not? What answer I wrote? Correct or not? Fast. See here, settlement effect is more than the load effect. That's why it came. See, here anti-clockwise, clockwise. Both are anti-clockwise. Here it will add up. Here, because this is more, it changed the loading pattern. Okay, start. Okay, now further. Over. Now not much work, very little work. Same problem. Throwing, after work over, throwing randomly somewhere. I don't know when I will learn this one. High time, I should do something. Better hang it to the neck only. Okay. Now, this member over, I will remove this one now. See. Start. After AB, see correctly, now it won't take much time. Consider BC. No. Consider BC. Now fast over. Consider BC. When you consider BC, first you see B and C here, loading. Loading is UDL of 30 kilonewton per meter. Okay, right there. 30 kilonewton per meter UDL. This is B, this is C. Span is how much? Span is 6 meter. Okay. Now, therefore, this is anti-clockwise, this is clockwise. Formula. WL square by 12. This also WL square by 12. This is due to loading. Then below draw 2 parallel lines. Correctly see where is B and where is C. Tell me which support is below. When I consider AB, A is above, B is below. When I take left side is above, right side below. When I take BC,
Tell left side B is below or A is below. Fast. When I take BC member, which is below? Which is below? B is below. Therefore, support B is below. C is above. So elastic curve will go this way. Okay. Okay, side break. This is B and C. And somewhere here, tell correctly what is delta equal to. Answer. Tell me. This is comes down by 16, comes down by 4. Tell me delta equal to. Fast. Delta equal to 12 millimeter. 12 millimeter or 12 by 1000 meter. Okay, now, since his member is this way now, both FPMs are clockwise. Clockwise. Formula 6 EI delta by L square for the member BC, 6 EI delta by L square. And remember, for member BC, don't forget, it is 3 EI is there. Be careful. Nannannu marayabedi. Okay, start. M bar BC. Then M bar CB. Start. Due to UDL, anti-clockwise, minus WL square by 12. 30 into 6 square divided by 12. Due to delta, clockwise, plus 6 into EI. What is the EI? 3 times of 18,000. 18,000. Delta is 12 by 1000 divided by L square is 6 square. Answer, if you tell me, I will write M bar BC, that side, clockwise, plus 30 into 6 square by 12 due to UDL, then again plus 6 into same formula, 3 times of 18,000 into 12 by 1000 divided by 6 square. If you tell the answer, I will write. Otherwise, leave it. Are you telling the answer? Don't give wrong answer. M bar CB first. You should tell M bar BC first actually. You should give M bar, why you did M bar CB first? M bar BA na. BA is already over long back. M bar BC now. See, why you are giving long 18 na? M bar BA plus 18. Okay. If wrong, correct it. M bar BC, M bar CB. M bar CB is plus 198. Okay. Subject to verification. See, now there is no mistake. You write there. Suppose what answer one of you gave, if it is wrong, correct it. That is not a problem. My expression is perfect. Clear now? Answer, don't worry now. Another 2 members, I do not want answer. Clear now? Member BC, fully clear? Fast. Member BC, fully clear? If clear, I will go to next member. Now over, very within 5 minutes, everything will be over. Okay. LRC means this. What is LRC? LRC, giving code word back to me. LRC, left, right, center. Left, right, center comes to Suvarna News. Clear. Okay. Clear LRC. Okay. Next member. Left, right, center comes to Suvarna News at 8:30. Consider CD. Okay. See. First loading. UDL is there once again. This is C, this is D. UDL of once again 30 kilonewton per meter. Span is 4 meter. Okay. See here, FPM, anti-clockwise, WL square by 12, clockwise, WL square by 12. This is usual. I am not explaining. Then, draw 2 parallel lines. Start. Tell me, you are covering C to D. Tell me, which is upper side? When I do A to B, A above, B below. When I do BC, B below, C above. When I do CD, which is upper side? Which is upper side? C is upper side and D is lower side. So somewhere outside, delta equal to, tell me delta, 4 and 24, delta. delta equal to L delta over one more member delta 20 millimeter. See, why 20? Sorry, high school question, or 20 by 1000 meter. So elastic curve will go this way, and now see goes this way. Both are anti-clockwise. See there, both are anti-clockwise. Formula 6 EI delta by L square for this member. This also 6 EI delta by L square for this member. Don't forget that member has got 1.6 EI. Nannannu marayabedi. Okay, start. Almost over now. Just another only 5 minutes left out. Only 5 minutes more. For last part now. M bar BC. Start. M bar BC. See here. Anti-clockwise minus W 30 into 4 square by 12. Once again anti-clockwise minus 6 into, don't forget, 1.6 times 18,000. Delta is 20 by 1000 divided by 4 square. Don't give the answer. I am not writing. Why should you waste the time? Okay, some answer. M bar CB. Don't give the answer. I am not writing. M bar CB clockwise plus 30 into 4 square by 12. And this is anti-clockwise minus same as that one. 6 into 1.6 into 18,000 into 20 by 1000 divided by 4 square. Get the answer. Tell me. You just tell me clear or not. Answer not required. Answer ಬೇಡ ಬಿಡಿ. ಯಾಕೆ ಸುಮ್ಮನೆ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡೋದು ಬೇಡ. Suppose wrong means correction. Clear means sufficient for me. Answer not required. Clear. Okay, now last member. See, when everything is clear, why you want answer? Now last member. Last member. CD. Over. So last part of pre-requirement CD. See, first CD is like this. C and D. One point load, I don't know how much it is, 20 kN rubbed out. 20 kN point load, span of member is 6 meter, load is exactly center. Therefore, formula is central load WL by 8, WL by 8. This is already known for you. Now, below and don't forget, it has got 2 EI. Don't forget this 2 EI. Now, below draw 2 parallel lines. Okay, I will tell you. See, D is below, E is above. So elastic curve will come like this. If it goes this way, both FPMs are clockwise. Same formula. 6 EI delta by L square, 6 EI delta by L square. 1 point you write. Somewhere outside, tell delta. Delta. This goes down by 24, that goes up by 9. Delta. Delta. Delta is 33 millimeter. 33 millimeter or 33 by 1000 meter. Okay, now start. Last part of this one. Okay, who will go for paper? M bar BC, M bar DE is anti-clockwise minus 20 into 6 divided by 8. Next one is clockwise plus 6 into respective EI, 2 times of 18,000. EI delta is 33 by 1000 divided by 6 square. Get the answer. Don't type the answer. I am not writing. Lastly, M bar ED. It is due to loading clockwise plus 20 into 6 divided by 8. Due to settlement also clockwise. That also plus. Plus same thing. 6 into 2 times of 18,000 into 33 by 1000 divided by 6 square. Get that answer also. Both will come in kilonewton meter, Now go for SD method or MD method or Kari's method and finish the question. Okay, fully clear how to account for delta if the settlements are given for a continuous beam. Fully clear? That's what I want. If fully clear, okay, done. No, answer ಬೇಡ ಬಿಡಿ, ಯಾಕೆ ಸುಮ್ಮನೆ ಯಾಕೆ ಇಂಕ್ ವೇಸ್ಟ್ ಮಾಡೋದು. ನಾನು ಇಫ್ ಐ ರೈಟ್ ದ ಆನ್ಸರ್, ಸಪೋಸ್ ಮಿಸ್ಟೇಕ್ ಇಸ್ ದೇರ್, ಎ ರಾಂಗ್ ಆನ್ಸರ್ ವಿಲ್ ಬಿ ದೇರ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ನೀವು ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ಫುಲ್ ಕ್ಲಿಯರ್ ಹೌ ಟು ಅಕೌಂಟ್ ಫಾರ್ ಸೆಟಲ್ಮೆಂಟ್. Tell me, if full clear, fast. Okay, now we will enter displacement method, slope deflection method, moment distribution method and Kani's method. Remember, YouTube class will close today. No more. I first thought for those three methods, three important concepts, that flexural stiffness when the far end is fixed end and flexural and carryover factor, let me give today only here, and also other things. Then by seeing the response I decided no, that is required for SDMD Kani's method. I will tell in the course only. So with this one I am stopping now. Now onwards these classes, BSK classes, will not run on YouTube. It will run only in Zoom. So I will send the link. It will continue in Zoom. Therefore I will talk to you later. Those who are regular, I will talk later. Continue there. You don't have to register. Those who are in the BSK batch, you are already in the batch. So I will continue there. And all the pre-requirements, I told, FPM calculation, formula and all these examples are thoroughly to be studied before you start displacement methods. Fully clear? Now, ready for displacement method? No. Now, ready for displacement method? Pre-requirement part is over today. That's all. I would have given little more, but they don't deserve. First I told, this displacement method also I will do what? In YouTube only. But I think people don't deserve it. No. Undeserving people, I do not want to give it. Kannada, it is called apatradana. Heard of it? In Kannada, it is called apatradana. You should help those who really deserve it. Those who deserve, you should help. Not the people who are not interested at all. Not, they may see the class later, but at least some response required. Just coming and going, it actually irritates actually. Okay, thank you. I'll talk to you later.